So, I hope you all enjoyed the two videos that Micah presented on Python, the history, and everything else, and particularly the second video where you got your real first picture of what it takes to program in Python. I'm going to urge you all that if you're confused or anything else, you need to reach out to somebody, right? You can reach out to me. There are tutors available. You need to reach out to someone. This is the basics. This is easy. And if you're getting confused, if you get confused, this it's not going to get any better unless you talk to someone and talk about it. So again, highly encourage you to reach out to me. My job is to help you, and I take that very seriously. And so if you've got problems, reach out to me. I've had a couple of your classmates reach out to me already, and I hope that they would report to you that I was helpful and I did get them through it. And I can do that for you too. This may be a very unfamiliar environment for some of you. So it's okay. I understand. I was there one day, once as well. There was a day when I didn't know anything about computers. And many of the concepts were difficult for me, and I had a lot of help. And so all I can do is offer that help to you as well. Okay, let's get on to this lesson. What's this lesson all about? Well, as I mentioned in the intro video to this week's lessons, my intent here is to continue to build on the idea of algorithms that we went through last week. You guys, many of you submitted your homework, not all of you yet. You might want to think about doing that if you haven't yet. Time's wasting. It's overdue. You're losing points every day. It's overdue. So, with that public service announcement out of the way, let's get to the meat of this. So I'm going to reflect back, let you see the algorithm that we're looking at. And I'm not going to go through that whole presentation again because in reality, there's really only one slide that I really care about that you guys need to know. And so let me flip real quick to it. Let me get to that slide for you so that you can look at it. Here we go. So remember this slide. Now I'm going to be kind of flipping back and forth between that and and something new that I'm going to introduce. So let me pop that up and let me do a quick switch change over to that, and voila, I believe you should be seeing that now. So you should be seeing the integrated development environment at this point. So this particular integrated development environment is different than Replit. This is actually, some of you may know about this because some of you may have been doing some coding, particularly with Microsoft products out there. This is actual Microsoft Visual Studio, and in fact, this is Microsoft Visual Studio Community Edition, which is completely free. It's offered up by Microsoft. It does not have all of the features of the commercial version of Visual Studio. However, it's very, very good, and it has a lot of very advanced features, many of which you're never going to get to. But it does support many different languages, and so it's a full-blooded integrated development environment. Now I've simplified this down, so as you can tell, to keep this short, I've already typed this out, and you've seen me type. You know that I fat finger things a lot, and even though I've been typing for decades now, sometimes I fat finger stuff, and I really don't want to waste your time. So instead, what I'm going to do is we're going to walk through that I wrote down here, and I'm going to make some comments, and then we're going to begin to see. Then we'll begin to do some operations. And one of the reasons why I wanted to do this in Visual Studio is because of what we can do. Now, so let's get on to this. So the first thing I want you to note is I started my program with comments, and you can expect it's a requirement. It'll be in the actual homework documentation. When you do programs, you must provide comments. And the first comments here are just simply to announce what the program's about, who wrote it, when it was written. Okay, that's all well and good. Now, how do we know they're comments? Because they start with this pound. I call it a pound symbol. You probably call it a hashtag. I don't really care. At the end of the day, it's that, that pound sign or hashtag, whatever. Anyway, when you put that there, all that does is it's a signal to the computer to ignore everything after it on that line. Just ignore it. Why do we have comments? Well, specifically so that you can communicate. You can communicate forward in time. If you think back to that first video, how did we get to the modern computer, right? It was all about recording information for a future time. And that does happen. There's code that I've written that still runs out there somewhere. There's stuff that I wrote decades ago that's still in operation. And so now it does not look the same as when I worked on it or when I completed it. It probably has been altered and changed by programmers afterwards, after me. Now, if they had gotten in there on much more complex programs than this, what frequently happens is it's like, what is going on here? Where's this? Where's that? In other words, someone else could spend an awful lot of time on a very complex program trying to figure out what you were doing and why. And that's what comments are there for. It's there not only for the future, but also for you. You might open this up 10 years later and you go, oh, okay, what was I thinking then? Why did it do that? This, that, and the other thing. Comments are your options. It is the opportunity for you to document in code why you did particular things. Some companies have very stringent rules about the types of documentation you need to have if you become a professional developer there. I know that at one place I was at, every single block of code had a very specific template of information we had to fill out on that code that talked about, what is this block of code do, what calls it, what does it call, who developed it, when was the last revision, and who did the revision, and what was the revision for. So there's a lot of documentation within the code itself. Now, in compiled programs, you don't really care because comments don't end up in the machine because the machine never would see it. The comments never make it into the executable code. Interpreters, no, it's going to be there. It's just that they're going to be ignored by the interpreter and therefore by the computer itself. So then what you begin to see is I'm just giving hints to the reader as to what this next segment is about. And in fact, more than anything else is that I broke it out into there's like these 3 segments out here. Remember I told you the other day that a program must do 3 things always. It's got to get some information in. It's got to do something with it. It's got to manipulate it in some way, some value-added thing it's going to do to that information, and then it's got to give that information to someone. It's got to output the information. So it's input, process, output. Always. So that's, as I said before, that could be your first 3 main tasks: is input, process, output. Obviously, each of those needs to have a little bit more detail, so that's where you do your stepwise refinement. So anyway, to remind you of that, I put a comment in here that get input. So this first thing is getting the input. And if you look back, this is awkward, I'm sorry. I have a better way to flip between there. I actually do, I'm just not thinking of it. Okay, what do we see here? We see, okay, ask for the first number, write it down on paper. Well, clearly now that we're talking about a computer program, we're not going to be writing things down on paper. Okay, that's fine. Let's see this. I'm going to move that over here for now. Great. Okay, so that works better. It's still kind of funky, and I'll probably figure out a better way to do this later on, guys. But for the meantime, let's, you know, give a little grace to the old man. Anyway, so we, again, if you were to go back through, if you had that slide sitting in front of you, you would see that it says ask for the first number, write it down. Well, what's the equivalent of that in code? Micah's covered it. How do you get input from the user? You use the input command. Now, one of the major things you must remember about the input command is that by default, it's going to assume it's getting a string. By default. Unless you tell it differently, it's going to assume it's a string coming in, which is all well and good. This first line here would execute. It'll execute fine, but it's going to put the string. So say I entered 20 here, 20. It's going to put the string 20 in there. But remember that 20 is not 20. 20 is, I'm trying to think, it's 16 plus 4, so it'd be 1, 0, 1. Yeah, 1 0 1 0 0. 1 0 1 0 0 is 6. It would be 20. 16 plus 4, right? That is the number 20. But if you put the string 20 in, what you're going to see is you're going to see probably something in the neighborhood of maybe 32 bits of ones and zeros that don't represent a number. They represent the code for the character. Remember I told you that we've got ASCII code or Unicode, and those, you may not know that. Come to think of it, that was on another video that I haven't released yet. So ASCII is the American Standard Code for Information Interchange. It is how we represent characters, individual characters and symbols and all the things that appear on your keyboard. We represent them with codes, not unlike Morse code, except typically you have certainly a lot more ones and zeros than dots and dashes that you have in Morse code. And that's because Morse code was only trying to represent letters. But in ASCII, we had to, which has been the standard for a long time, well, a standard for a long time, and the dominant standard for a long time. It can represent up to 255 characters. Okay, that sounds like an awful lot. You look at your keys, you probably have 100, maybe 100 keys on your keyboard. Okay, so why do we need 255? Well, because the character A, capital A, is different than the character little a. So, and then you look at all of the things that alter the function of each and every one of those keys, and you find there are hundreds, literally hundreds of actions and symbols that have to be represented by the key presses. And the other thing that really has driven things is notice the first letter in American Standard Code for Information Interchange, A. What does it stand for? American. Or is America the only one that uses computers now? No, certainly not. They're worldwide. Everybody uses them almost everywhere. And so consequently, in order to present information to other people that use other languages, we have to have other symbols. And when you get into things like international commerce, right, you need to be able to distinguish between the dollar symbol, or maybe the symbol for a euro, or the symbol for the British pound, or the symbol for the Japanese yen, or any other kind of currency. They all have their own very specific symbols. And so the whole point here is that you've got to remember that the string 20 is not 20. It is not the value 20. The value 20 is going to be that 10100 that I talked about, right? That's a number. And this goes back to the typing that Micah talked about, right? So the variable that you're putting this information into, in this case, first number, that variable is going to be automatically typed a string unless you tell it differently. How do we tell it differently? Because, well, I'm sorry, let me retract that a little bit. After you put your information in the prompt, by default, that parentheses around, actually, let me get the cursor. So these parentheses here, these innermost parentheses, where you have your prompt, when the user types in 20 for our example, it is going to pass it back, but notice that it is enclosed by another set of parentheses, and this goes to the casting function. And this is something else I believe Micah talked to you about, and that just says, yeah, I know that this is probably going to be a string. In other words, it's going to be 2 characters, 2 and 0. But in reality, I want you to treat it as a number, in which case what this function int will do is it'll convert it to that 10100. It'll convert it to that and store it as an integer and not as a string. And that becomes very critical because I know Micah talks about this. It's, we can add strings, but remember we're going to be doing adding strings is not the same as adding the numbers that the strings represent, number one. But you can add strings, but the result is not a mathematical calculation. That's one thing to remember. And the other thing is that you can't do is you can't divide strings. You can split them, you can do a lot of other things, but you can't perform the mathematical division function on strings. It doesn't make sense. You can't divide a string. You can't divide a string you can't divide a string by another string. You can't divide a string by a number. You can't divide because the concept of a word, how do you divide a word? Well, okay, I can take 3 letters here and 3 letters there, but that's, in the terminology of computers, that's not division. That would be splitting, and that's a function that's available for strings, and it's a function that you'll use. But so the important thing here is what you've got to do is convert what comes from the input command, which is going to be a string. You've got to convert it to an integer in order for first number to be integer. And we want first number to be integer because we're going to add first number to second number and third number, if you remember the algorithm, right? Okay, so I know I'm kind of belaboring it, but a lot of people struggle over this because they never get beyond the fact that, okay, I put something in there, but it's not calculating. I'm getting errors all over the place. And it's because you can't calculate a string. And it's hard to remember that by default, the input command is going to give you a string back. And it's your job to convert it to whatever you need it to be, whether it's an integer number, a float, whatever. So, in this case, we'd use the int function, and notice that we enclosed all of the input command including its own parentheses within the parentheses for the int command. So again, we kind of, when we're doing the assignment, everything has to be resolved on the right-hand side before it goes into the memory location, into the variable called first number. All right. So, there's a lot there. So, what's going to happen? Someone types in 20 for that first number. It's going to come back as a string through the input command. Then it's going to go into this integer function, be converted from a string to an integer. Then it's going to be assigned to first num. And that first num will be a integer. Actually, you can see already it's decided that it's going to be an integer. That's what this helpful hint shows down here, that it's going to be an integer. Okay, second and third are exactly the same. And notice that between each, I have given you comments that are exactly, almost exactly what are in the algorithm. Ask for the first number, okay? So from now on, it's kind of like if you go, if you could remember that if you're going to ask for something, you use the input command. And so ask for the second number, ask for the third number. Okay, so we got our information. Now we're moving into that second piece. Remember, I said three things. I'm going to say this over and over and over again because I don't want you guys to get lost. There is always a place to start. It's get input, process it, put output. All right. Add all three numbers together and label it S. So notice that what I did was I took the variable first number plus second number plus third number, and then I put it in a variable called S. This is why in the algorithm I talked about labeling it. Now again, I know Mike has covered this, but I'm going to re-emphasize this. What happens on the left-hand side is that when you use S for the first time on the left-hand side, that it will determine what its type is based on the information you give it. That's exactly what Micah told you, and that's what I'm telling you. Notice that each and every one of these, as I hover over, and by the way, this is a function of an IDE, is it tells me things that are not obvious from the text, and that's why they're very helpful. And IDEs, they vary in quality and capability across the board. But I would tell you Visual Studio is certainly one of the better ones, maybe one of the top ones out there. But at the end of the day, these kinds of things, this is Microsoft calls this IntelliSense. So if you hover over an area, it's going to try to figure out what you might want to know, and it's going to give it to you. So it says the third number is a variable, and it's an integer type. Second number is an integer too. Now we know that from talking about it up here. Why is it an integer? Because the input was converted to an integer value before it was assigned there, and that's that dynamic typing within Python. So we add these all together. So what's going to happen is the contents of first number is going to be added to the contents of second number. It's going to be added to the contents of third number, and then we're going to divide S by 3. Again, going back to, this is actually almost quote unquote what came out of the algorithm. Divide S by 3 to get the average and label it A. In fact, that is the. And now one of the things to notice down here is that the operator below is an integer division, and you need to keep that in mind, and I'm going to demonstrate this in a few minutes. But that means in an integer division that all you're going to get is the whole number part. So we'll talk about this again in a minute, but you have got to remember what integer division versus decimal number. Trust me on this. You must remember that. You must have a good handle on it. If you get confused, ask me, and I will try to clarify it. And then we see output, right? Communicate the result. Output. Print the average of. So notice that what we've done here is we put a string literal, as Micah talked about. We put a string literal within quotes. Notice that I put spaces out here. I do that, otherwise it looks, if you don't actually remember that an empty space is a character. And so if you need a space, you've got to put one in there. And because it's not, the computer's not going to guess that you need a space there between the words or the letters or whatever. And then notice that these things are all different colors too. And this is also part of the IDE, right? This red color indicates it's a literal. The blue color indicates that it's a command. The black color indicates that these things are variables. So there's a lot of clues here that can help you as you're moving through here to figure out what's going on. So here we go. All right, that's the program. That's it. Okay. So really, not much different than what we had in the algorithm. And again, Algorithms don't always map one-to-one. They oftentimes they don't. But but in this case it does, and you can see a direct relation between what we did in building out the algorithm and what is in the program itself. So the proof's in the pudding. Let's run it. Well, I'm going to go up here to the start button. No. Okay. Yeah, I did that already. So let's execute it. And I got a pop-up window here, and I'm going to say the first integer is 10. I'm going to say the second integer is 20. You can say the third integer is 30. You all can do the math. You know that the answer needs to be 20. So let's press it, and yeah, okay. And it tells us the average of 10 and 20 and 30 is 20. Notice all those spaces that I put in there, even the leading space are there. And then pressing a key to continue is part of the IDE's interaction. If it didn't put a pause in there, what would happen is you'd just scroll off screen. So in other IDEs, they may not necessarily do this for you, but you can get the same thing by creating an input statement, by creating basically a null input statement that'll accept any value. And then a prompt. So it'd be an input. You would create a input statement that said press any key to continue, and it would go to some variable that you don't really ever use. But that's a way that a pause can be accomplished in Python. So now, okay, you've seen that, and we could finish here. But there's some things I want to show you here, because I talked in the very first video this time around in the intro about troubleshooting and stuff like that. And I talked about that IDEs frequently have capabilities there that make the kinds of things where we used to have to enter breakpoints. I talked about them, which would be essentially something along the lines of what I just talked about. We would ask for input that we'd never need. It was just to stop stuff, right? And then we would use print statements to see, okay, what's the value of this variable at this time? Those were the major tools we used to troubleshoot in those days. Well, guess what? You can do that today, but it's a lot easier. You don't actually have to alter your code. So, for instance, what I'm going to do here is I'm going to go out here and click there, and I'm going to click there, and I'm going to click there. All right. And actually, I'm going to do one more. I'm going to go down here a little bit more. I'm going to click there too. Now, let's go back and run this again. All right. Now, one of the things I want you to notice is there's something out here that's called, it's labeled locals, but most of us would call it a watch, a watch window or a watch, a watch function. By default, what it does is it begins as each variable is created. Now you got to remember where we're at. We're at the start of this command. It hasn't executed yet. This yellow, the command that's highlighted in yellow. We're at this, but we're not. We haven't executed it yet. If we go down here, what we see in locals is a whole bunch of stuff that you really don't care about, right? These are environment variables and stuff like that. You would. They're valuable, but not for what we're doing right now. Same thing with globals. And essentially what we find is globals pretty much the same exact variables. So what we got is variables that are classified in two different ways or in two different buckets. At the end, it doesn't really matter. But at present, nothing really helpful here. Now let's continue. So we're going to get our prompt, hit our 10 again, press enter. Okay. Now look what happened. Now notice that the variable first number is now displayed, and we see that its value is 10. Okay, and that its type is integer. Okay, that's great. Now, this is going to be kind of somewhat ho-hum right now because we're not going to reuse these variables and we're not going to alter these variables. They're going they're going to get one value and it's going to stay that value. But that's just because the ultra simplicity of where we're at. Later on, though, we're going to be doing other things, and it will be very helpful to watch what happens to the variable as the program executes. So this is just a brief introduction into the what's going on. But what I want you to do is really definitely tie your mind into the fact that, okay, this is actually what this is doing is reading the memory location that is named first number. It's telling you this is what's in that memory location. Now we're going to go through and do this the second time. The second time you're going to find that, oh, first number is not 10. It's something else, whatever I put in, right? So, all right, let's go on and let's continue. And we're going to enter again, just to continue the example we were using previously. I'm going to do something different in a bit. And notice now second number appears and the value is 20. It's an integer. Okay, cool. As you kind of would expect, having seen what you did. Let's go, okay, one more time. And now we got our third one. And, okay, and it finished up. I actually thought I had put a break in there to take a look at what was out there. Maybe, but, you know, okay, let's, real quick, let's go out there and look. Yeah, you can't see it because the command box is open. All right. I'm sorry, I thought I had put the one here. Okay, yeah, I'm going to put another breakpoint there. That's what we call that, is a breakpoint. So I'm clicking off here to the left, and you see these red dots here, and that tells us that breakpoints are set there. All right, let's one more time. Okay, this time, okay, we're at the first number. Hasn't quite given us the prompt yet. No variables. Blah. Go out there. This time we'll, just for grins, we're going to do something slightly different. This time we'll do 10. And, okay, nothing different so far. Okay, and then we're going to continue again. And this time we're going to enter 7. All right, so it's different. And we would hope, and sure enough, we see the second number is 7. So those variables that are created only exist while that program is running. When the program is done, all of that memory space is returned, and when you execute it again, everything is recreated. Now, if you needed to save those results outside of the scope of the program, you would have to write it to a file of some sort. Or to a database or whatever. You'd have to save it to a stored location that would remain after the program. And that is going to be pretty much beyond the scope of what we're going to cover today, but those are the kinds of things that we have to learn how to do later, like how do we write to files, how do we read files, how do we maybe send something to a database, how do we ask for information from a database. Those are all the kinds of things that Python's perfectly capable of doing. In fact, it's capable of creating its own database as part of one of the extensions. So, you know, there's a lot of capabilities, a lot of things to learn. We're not going to do that in a month. We're going to learn some very, very basic things. But what we are going to be learning is we're going to be learning things that are true about every programming language. They all have to do these things almost all the time. They have similar names. You know, there's other syntactic things like, do you need curly braces? I'm pretty sure, I remember that Micah talks about that. Curly braces, which you use a lot in C, or a semicolon, or any of these other special characters to indicate what's going on. Python doesn't use many of those, but the basic core functions, the kinds of things that have to happen, like input, for instance, or print. For instance, C has a print command. The only difference is it's called printf. All right. That's, most languages have some command out there, and it's some variation on print because you want to be able to give output. Now, that's all I'm going to get into on that one. So, and I could swear, did I not put one there? I did. Oh, no, I did not. That's right. I put it down here. Okay. So let's do our third number. Okay, and then we'll do 30 again. And so now, and again, we see, notice that S has become full. S now exists. It didn't exist before. So if we were to look at the command lines above, here's S. It took what was in first number, which was 10, and then in second number, it added 7 to that. It gives us 17. Add 20. Add 30. That's 47. And as you can see, that's what's put in S. So it took what was in first number, added it to second number, and added a third number, and all of those added up together, and then placed the value, that the result of that calculation, that operation, the addition operation. That's what the plus symbol is. It's called the addition operation. The addition operation completed twice here, and then so we got the total was put into the variable called S, and we see it's now an S. And then remember what we did was an integer division here. This is the integer division sign. And I even put in a comment here to raise awareness. It's the integer division sign. Again, I'm going to say this again and again and again. You must understand integer division versus decimal division. You must understand it. You must understand what it means. Now, in this case, what it means is if S divided by 3 has a whole number and a fractional part, all that we will return is the whole number part. So if I were to pull up my handy dandy calculator here real quick, and let's say we had 47 divided by 3, we see that the answer is 15.66666. No. What is our answer going to be? Well, drum roll please. The answer is 15. Exactly as I told you. Because we did integer division, it's only going to return the whole number part. Okay. Now, that can be useful. And there are times when all you want is the whole number part. And you need to, that's very useful in doing things like figuring out, as I think I said somewhere, sometime in there, is like, well, how do you have half a person? If you do the decimal division, or if you will, to go back to our calculator here, we have 15.6666. Say that was a calculation. That was the average number of people. Well, can you have 15.666 people? What's the 6666 people look like? Probably don't want to know. That's 2/3 of a person, right? Okay, which parts are missing? That's pretty nasty to think about. At the end of the day, you got to remember this. Trust me on this one. You've got to remember it. You've got to understand it. And if you're confused, you better get with me on it. Okay, enough said. All right, we finished that one out. Well, that's really all I was going to show you here. And it took some time. I get it. But there was a lot to see. And again, this kind of IDE may not be the kind of IDE you're working in, but I did want to talk a little bit about that troubleshooting, because even in the basic, so for instance, if you were to load Python on your personal machine using the distribution, the official distribution, it comes with an IDE that's called IDLE, IDLE. It's helpful, but not real helpful. Not this kind of helpful. Not this good. And so, but there are plenty of other IDEs that are like this, that are this good. But the essence of it is I wanted to show you this. And again, by the way, if you decided you wanted to have, now, I would say you probably don't want to load Visual Studio on the Community Edition on your machine unless you're pretty comfortable with doing that. It loads straightforward, but getting in there and coming to grips with where things have to be and where they are and all that, it takes some time. And I've been using Visual Studio for almost 5 years now. So, and there's tons of things I don't know about it yet. It has a lot of capabilities out there, but but it is free. And if you have a computer and you're comfortable installing it, you can install it and use Visual Studio and take advantage of these kinds of things. Idle is a decent IDE. It again not as full featured as this, but again it'll still kind of get you where you need to go, and that's part of Python. So you could go to python.org. You could download their official distribution for the operating system that you're on, whether it's OS X for Mac, or it's Windows or Windows for a Windows machine. Download it, install it, and then you'd have an application that was running on your PC that would allow you to write your programs, save them as files. These are files, and I've got them saved. I just resaved them there, and you can open them up later and use them. So that's really all I wanted to cover. I wanted to see you make that move. I wanted you to see that movement from, okay, here's an algorithm to here's a program, and to see how directly they map, and so how it can be so useful to have done an algorithm ahead of time, because it really does kind of map out. Then all you do is convert those sentences in the algorithm to the appropriate code. Now, it's not always going to be straightforward. It's not always going to be easy. But again, starting with a plan, you're going to be in a much better place than if you start with a blank sheet of paper. So, with that, we're going to leave this. We're going to finish this lesson for tonight, and I'll look forward to hearing from you all later on this week with your various different assignments and quizzes. And I think, as I recall, there's a program that's due, and I don't remember where. It's not. I don't think it's due at the end of the week. I think it's due next week. But you're going to be writing your first program. So, any questions at all, get a hold of me via email. Unfortunately, that's about the only way to get a hold of me is via email. But most of you know that I'm on almost every day, and I'm certainly on Monday, Wednesday, Friday, and between 10 and 12 for sure. But usually before, after, and or even as you see here, at 11 o'clock at night. So, all right, everybody have a great one. I'll look forward to seeing you very soon.